So in this video, we're going to work on uh, reaction number 2, or example number 2 in this in this topic right there. We're going to use the same process as we did before. So we are going to identify the spectator ions, and in this case, we've got two of them. The chlorine is a spectator ion, and the potassium is a spectator ion. So we're going to have in the other category, once we're all done, we're going to have K plus and Cl minus. Okay. We've also got the case here where we have a weak acid that is, a strong acid that is being added to a solution that has both a weak acid and the conjugate base. So the reaction is going to look like this. We'll have H3O plus from the HCl that reacts with the base component. So it's going to react with CH3, CH3COO minus, and it's going to give us CH3COOH and water. So let's keep track of our moles and our initial amounts. We have 0.15 moles of the HCl, and we have 1 liter of the other stuff that is 1 molar in both the acetate and the acetic acid. So we're going to have 1 mole of acetate and 1 mole of the acetic acid. Now again, we do a change, which is zeroing out the limiting reagent. So minus 0.15, minus 0.15, and plus 0.15. Okay, sum all of those up, what the final amounts are, and we have 0. We'll have 0.85, and we will have 1.15. Okay, so we've got the CH3CO minus in solution at the end. So we're going to have this stuff in there. We're going to have the acetic acid in there. And we're going to have the spectator ions. So the acetate is going to be a base. The acetic acid is going to be an acid. So we would list both of those under the corresponding categories. All of the H3O plus is used up. And that is it.